Right, the last section of chapter 4 is 4.3, and it's trees and counting techniques. So we're going to be looking at things like factorials and permutations, and to start out, tree diagrams. So a tree diagram, let me just make sure I'm recording here. Yes. All right. A tree diagram displays outcomes of an experiment involving multiple steps, in other words, a series of events. Take a look at example 11 on page 167. So here's an example of using a tree diagram. You have a bag containing two red marbles and 3 green marbles. Draw a tree diagram for drawing 3 marbles from the bag, and then write the associated probabilities with each draw. Okay? So here's your starting point. This goes left to right. So what we're doing is, here's the first draw. If you got a red, you're going down this or up this way. If you got a green, you're going down this way. So let's say here's your red on the first draw. Then you draw again. Now notice it only contains 2 red marbles. Here's your red on the second draw. Okay? And so we're going to calculate this probability of red on the first draw and red on the second draw. Just keep in mind, there is no red on the third draw here because there were only 2 red marbles, okay? And so then write the associated probabilities with each draw. By the way, the more branches you have on this tree, the messier it gets to do it this way. You can already see how it's branching off here. Each time it's getting consecutively more branches as you're going to the right. And something like this can get a little bit unmanageable at times, depending on how many draws that, or depending on the number of draws for experiment that, or for example, that you have for that particular experiment that you're doing. But at any rate, this is a basic, easy to handle tree diagram. So for example, here's the top row of the diagram's probabilities. Here's the probability you're given red on a first draw. It's going to be 2 out of 5. The probability you get a red on the second draw, given that you got a red on the first draw, that's this right here, is 1 over 4. Okay? And then the probability of green on the third draw, given red on the first and second, is 3 out of 3, 3 over 3, which is 1. All right? So what I'm going to do is I'm going to go down. Here's what I'm going to do. This looks sort of messy, and I'm going to zoom in on it some here, and I didn't fill out the entire chart, but I filled out enough to where I think you'll understand what's going on. So, oops, here we go. Here's our starting point, and I'm just going to handle with red on the first draw. Okay, well, then I did green on the second draw right here, or green on the first draw here at the bottom branch. But let's say you get a red on the first draw. The probability you're going to do that is 2 out of 5. Supposing that you did that, you successfully got a red on the first draw. That means you no longer have out of 5 marbles. Now you have out of 4 marbles. So out of those 4 marbles, how many of them are red on this second draw? Only 1 of them, okay? So that probability is 1/4, which means here, this last draw, there are no reds. You're only going to get a green. All right. So the probability of a green on the third draw, given that you got a red on the first and a red on the second, is going to be 3 over 3, which is 1. You're definitely going to get a green ball on the third draw if you go this first route up here, right? If you get a red on the first draw and then a green on the second draw, you no longer have 5 marbles, you have 4 marbles, but you still have 3 greens in there. So that probability is 3/4. So if you go up this first branch and then go down, the only thing you're going to get is green. Notice that the probability on the second draw of red plus the probability of green add up to 4/4 or 1. That's going to happen every case where it branches off. Like this last branch right here, there's no reds to branch off to. So you're definitely going to get a green on the third draw. The probability is 3/3, which is 1. I tried to color code this to make this easier to follow. All right. So the probability you get a red on the first and then a green on the second is 3/4, right? And then let's look at the third draw. The probability you get a red on the third draw, given that you got red on first and green on second, is 1/3. There's only 1 left. Out of now, there's only 3 marbles in the bag. The probability that if you got a red on the first and a green on the second, the probability you get a green on the third is 2/3. And these have to add up to 1, okay? And then down here, if you've got a green on the first draw, that's 3/5. All right. And then see if you can fill out the rest of these, is what I would recommend. All right. See if you can fill out the rest of those probabilities. Multiplication rule of counting. If event A has n possible outcomes and event B has m possible outcomes, then event A followed by event B will have a total of n times m total possible outcomes. Take a look at the multiplication rule of counting and example 9 on page 165. Here's an example I made up. It's not in your textbook, but it gets the point across. You go to a cafeteria. You pick one of each from the following categories. For a drink, you can have coffee, tea, or a soft drink. For bread, you can have cornbread or a roll. For dessert, you can have Jell-O or ice cream. For a salad, you can have a house salad, slaw, or potato salad. For meat, you could have ham, spam, or lamb. Let's say you're going to pick one from each of those. So how many total outcomes are possible? Well, notice for the drinks, there's 3 outcomes. That's this 3 right here. For the bread, there's 2 outcomes. That's this 2. For dessert, Jell-O and ice cream, that's 2. For salad, you have 3 outcomes. That's this 3. And for meat, you have this right here. So all we're doing is multiplying those together. 3 times 2 times 2 times 3 times 3 equals 108. You have 108 total possible outcomes. So what's the probability that a person selected these particular options? Tea to drink, slaw for the salad, roll for the bread, spam for the meat, and Jell-O for dessert. Well, that's 1 out of that total of 108. 1 divided by 108. Factorial notation. This can be used to calculate the number of possible ordered arrangements for n objects. So take a look at factorial notation and guided exercise 11 on page 169. So the definition of factorial, this exclamation point is factorial. N factorial equals n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1. 0 factorial is defined to be 1. 1 factorial equals 1, okay? So for example, how many different ways can 3 books be arranged in order on a shelf, right? So assume the books are numbered 1, 2, and 3. We'll call them book 1, 2, and 3, right? How many different ways can you order it? Well, that would be 3 factorial. 3 times 2 times 1, which is 6 different ways. So here's the 6 different ways those books could be ordered if they're book 1, 2, and 3. They could be ordered 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 2, 1, and 3, 1, 2 in that order. Oh, actually, before I go, let me pause this. I want to show you how to do this on a graphing calculator. All right, let me double check that I'm recording. Yes. All right, so for this example that we just looked at and how many ways can 3 books be arranged, and it's 3 factorial, on your graphing calculator, just type the number 3, go over to the math key, press math. If you look at the top, you see math fractions, changing decimals to fractions is highlighted. We want PRB for probability. You can either arrow to the right until you get to PRB, or you can arrow to the left until it's highlighted. And we're doing factorial. That's number 4, the exclamation point that you see, or exclamation mark that you see here. So you can either arrow down and press enter, or just press the number 4, right? So let me do this. So I'm going to type in 3, math, PRB, 4. We get 3 factorial. We press enter, we get 6. What if we want to arrange only some of the n objects, not all of them? For example, we have 10 students. Let's do this. We have 10 students and want to arrange seating for 4 of them. So it's no longer, it won't be like 10 factorial, right? These are called permutations. The number of ways to arrange n distinct objects in order is, now on your calculator, this is going to be NPR, but in the textbook, it's PNR. The probability of n items r at a time. The definition of that is n factorial divided by n minus r factorial. And see the counting rule for permutations, and then example 12 on 169. Now, we're going to do this. I'm going to show you how to do this on the graphing calculator. All right. So let's say I have students and I'm going to take them on a trip to Vegas. I'm going to randomly pick 2 students from my class of 25, total of 25 students, to accompany me to Las Vegas on a probability study field trip. Okay, we're going to go to a casino, actually. The first student travels with me in first class. The second travels coach. So order here counts. When order counts, you're doing permutations. So how many ways can I pick 2 students from the 25? So we have here that n equals 25 and r equals 2. And you could go through and use this formula right here using the rules of factorials, and in your book they can show you that, but we're going to use the graphing calculator. All right. So what I'm going to do is n is going to be 25. We're going to type 25. Then we're going to press the math key. Then we're going to arrow. You can arrow to the right to PRB, or just arrow once to the left and highlight it. We're doing permutations. That's number 2 right here. So you could either arrow down and press enter, or just press 2. I arrowed down to show you where it was. So let's press enter. All right. And then what's r equal to? That's going to be 2. We're going to press enter. And we get 600. So there's a total of 600 permutations of choosing or of picking 2 students out of the 25, right? So what's the probability that I pick my student Allison first and Tasha second? Well, that's going to be 1 divided by 600. That's one of those permutations out of those 600. So that's when order counts. Let me clear this. So when order doesn't count, we're using what are called combinations. So the number of combinations of n objects taken r at a time, the combination of n things r at a time, the way your book has it, again, our n is going to be in front of the c and our r is going to be in the back. That's n factorial over r factorial times n minus r factorial in the denominator. The denominator here is bigger than for permutations, which means the fraction overall is going to be smaller, okay? So here's trip to Vegas part 2. Oh, see counting rules for rule for combination and combinations, and then take a look at example 13 on page 170. Trip to Vegas part 2. I'm going to randomly pick 2 students from my class of 25. Notice N and R are the same, so you can compare the two, to accompany me to Las Vegas. Both are going to travel with me to first class, so the order that I pick them in doesn't count, unlike permutations. How many ways can I choose 2 students from 25? By the way, generally, when you're using permutations, instead of choose, you would say pick. And when you're using combinations, they tend to use the word choose, all right? So that you know which one is going on here, permutations or combinations. N is 25, R equals 2. And again, this time we're doing combinations as opposed to permutations. So we're doing a combination of 25 taken 2 at a time. That's going to end up being 300. All right. So let's do that one on the calculator. I'm going to type in 25, my total number of students. We're going to go to math. I'm going to arrow left to probability. This time we want item 3. I'm just going to press the number 3. NCR, and then R was 2. And then we'll press enter. And so we get 300. There's 300 ways that can happen, or 300 combinations, if you will. So note that for combinations, again, order doesn't count, but with permutations, it does, okay? So if you're wondering which one should I choose, look and see if order counts or doesn't count. Anyway, look over any other examples in this section that you feel that you need to get more experience or more of an explanation. And then here's the recommended homework out of this section: 9, 11, 13, 15, 17, 19, 21, and 25. And don't forget, once you look through those or work over those, you got the tabs you can press that'll tell you the answers to that.